You're right.
Well, it was fair game. I can't complain. It was a good...
Stuff happens, accidents.
Yeah, no one's perfect.
No. So when are you going to get checked out?
I'm going to go to hospital tomorrow and get some sort of image.
Image? Is that going to be like a crayon drawing? Are they going to like sketch it?
Probably not, True. Probably not. No, they're going to do either an NMR or an MRI scan. I don't know which yet.
I think they're the same thing.
Do you?
Yeah.
Well, let's teach that then.
Good idea. So they're both, well, they both can be used for imaging or just looking at stuff.
Yep. So NMR, nuclear magnetic resonance.
Yep, and MRI, magnetic resonance imaging.
Nuclear is a scary word.
So they changed it in hospitals to MRI. People then go, oh no. But we're going to let you use NMR because you're brave.
You're brave.
And you can do it.
Well
we believe in you.
I'll give you a sticker, but I don't have any stickers.
Ran out of lollipops.
You ate them all.
Sorry about that.
So, I'm going to ask you a question, True.
Alright, I'm ready for questions.
What do all of these things
Mm-hmm.
have in common?
It's like only connect. Better. Oh, I can't do the theme.
Countdown.
Countdown. Always counted on my head.
You're just mixing up shows.
I know. The Eye of Horus, please.
Clever Cracker Squared on the Leno Show.
All odd numbers, Wayne.
They're all odd numbers, I got it straight away.
Oh, fantastic. Do I get a prize?
No. So, what does that mean?
Well, it means that any protons and neutrons, the numbers of which aren't equal.
Exactly, and when they are equal, the protons have one spin, the neutrons have another spin, and they pair up and cancel out.
However, when they're not equal, these do not cancel out, so there is some stray protons and neutrons just sort of chilling without a friend.
Yep. So there'll be one proton that's just spinning on its own. And
That
that would give some sort of extra magnetic field that is unwanted.
Yeah, or just unbalanced at least.
Yeah.
Normally, if you have a proton just floating about in your body.
Yep. It's sort of at a random angle, whatever it wants to be.
It's not being pulled in any direction, so it will be whatever it fancies in its surroundings.
And you can sort of think of it as having a north and a south, because it's a magnetic field.
Mm-hmm.
It causes, you can sort of think of them as mini magnets.
Yeah, you can. And if we put lots of mini magnets in an electric field.
Yep, a strong electromagnet will have a very north and very south, so it's going to give a strong field.
Then we can turn them all to face one way. Mostly.
Mostly, yes.
Some quite rebellious protons say, oh no, not doing that today. And they'll go the north to the north side and the south to the south side, which is not, as you know, how magnets want to go.
Yeah, and that would be this one, in this example.
Yes,
so, we can still make it flip the right way.
But we need to put some extra energy in. We use this energy in the form of radio waves.
Radio waves, and the radio waves' frequency would differ for the different energies, because that's how you give different energies with radio waves, is differing frequency.
Yeah.
And the frequencies of different things can be compared, and that's the next bit. This is the parts that you actually have to start knowing.
Yeah.
Because this so far is sort of an overview, you don't need it.
No. But yeah, as Wayne said, you can tell what it is, because this is a higher energy state, and if you put a radio signal in, same energy, it'll flip. And then go back and forwards, and it will make resonance.
And that is the resonance, that's important. Excitation to relaxation.
Yeah, and that's what the resonance is. But as Wayne says, the chemical shift is important.
Yes, so chemical shift is normally represented with a, what's it called?
Delta, is it?
Delta, is it?
Can't draw a delta, Wayne. You draw a delta for me. I
I'll
forgot
draw a
how to draw a delta.
Don't go out like that.
Oh no, that's bad. I was just
Something
going the
like
other way. Alright.
And it's measured in parts per million,
Yeah.
which is a rubbish unit.
It is a rubbish unit.
But that's the chemical shift, and that's sort of a comparison of the frequencies needed to flip things.
And that's particular for certain elements.
Sorry. So to have some sort of scale from 0 upwards, we need some sort of comparison, something to call 0.
Yeah, so we've chosen something, well, not us personally.
I haven't done much to choose this, to be honest, but I agree with them in their choice.
I think they did well. They chose, and they shortened the name off to TMS, but that stands for...
That would be accepted, by the way.
Yeah, TMS is fine. I'd go for TMS because it takes up less time in your exam.
If it's tetramethyl saline.
Yeah, or silane, I think.
S-A-L-I-N-E.
Or the other way around. Yes, but that. And that is R0.
Yes, and the good reason for that is that it looks... I think it's S in the middle, and it's got methanes around each side, it's got 4 of them.
Mm-hmm.
So all the hydrogens, the protons, are actually equal.
Yeah.
They're all, there's nothing special going on.
No.
And so it gives a nice, clean, sharp peak for comparative reasons.
Which is cool. So as that is 0, then we can move on to other things. When we're actually testing them, we do get into a few problems anyway. So often test it as in a solvent.
Yep. And so sometimes we'll need some sort of solvent.
But most solvents have this unbalance, so they'll come up on our signal.
So we need something that definitely has protons and neutrons balanced out.
Yeah, so there's a few of these, and we'd also like to have hydrogen if it can, so this is then it's just protons and stuff. So we choose deuterium, which is an isotope of hydrogen.
And it has
A proton.
2 nucleons.
Yeah. And neutrons being protons and neutrons, it's got one in each, which is quite nice.
So they pair up and it doesn't show up on the scan, it doesn't affect it, and that can be used as your solvent.
Which is pretty handy.
And then you can put it in and it'll give you some peaks. Normally when you put stuff into the solvent, you also put in a little bit of the TMS
Yeah.
as a reference point.
So you see sort of where you're going from, yeah.
You don't have to. If you didn't put that in, it wouldn't give you that sharp peak, but you could just look in other data books for where that sharp peak would be.
Yeah.
Normally they'd put it in with it.
But just in case it's something that's changing all of the results a little bit.
Yeah, it's a
So
good thing.
That would be moved.
And this is all good for comparing lots of different things, and the protons in different tissues
Yeah.
will differ. So I can see how badly my leg was
Yeah,
damaged.
so they can look at how that worked, which is lovely. I don't know who left that Lego brick there.
I hate Lego on the floor.
So